Hi and welcome to the next video in our ongoing series of lectures. In this lecture, we're going to learn how to find a molecular formula when you have empirical formula available to you. Now, keep in mind, empirical formula might be given or it can be calculated. So just because it's not given does not mean that you cannot find molecular formula. So we need to keep that in mind. Also at this point, it would be a good idea that you should pull up your notes so that not only can you write stuff down, you can also refer back to your notes from the previous video. Now before we go any further, it's very important that we learn what is a molecular formula, what information do you get from a molecular formula, and what does it represent. And so as you can see, molecular formula is the exact number of atoms of each element in a chemical formula. So when I say that the formula is C2H6, it means that it has 2 atoms of carbon and 6 atoms of oxygen. Okay, and that this ratio 2 to 6 can be reduced. Now for this particular chemical, whose molecular formula is C2H6, you can find its empirical formula by simply reducing the 2 to 6 ratio, and so in that case the empirical formula would be C1 and H3, and clearly you cannot reduce this any further. And so not only does it tell you the actual number of atoms of each element, it also tells you the exact number of moles. And so it means that when you look at this formula C2H6, it means that the mole ratio of carbon to hydrogen is 2 to 6, which is the same as 1 to 3, which means that for every 1 mole of carbon you have 3 moles of hydrogen. So this is all the information that we get from a molecular formula. It is important that you note this down, because down the line when we do stoichiometry and find moles of individual elements, this technique is going to be very handy. So let's get started with the actual process. Now in this particular section, you need 2 things to figure out the molecular formula. Number 1 is you have to know the correct empirical formula, and this will either be given or it also can be calculated. So when you see a problem where they don't give you the empirical formula, do not stress over it. What they will give you is the percent composition. So as long as this is given, then you should be okay. And then the second piece of information you have to have is the molar mass, and this will always be given. You cannot find a molecular formula if you don't have the molar mass. Alright, so moving on, let us go to the actual step. So step number 1, you are going to find the empirical mass. So what is empirical mass? Empirical mass is basically the same concept as molar mass. So if you remember how to find molar mass, then you already know how to find empirical mass. Empirical mass is basically you take all the elements, find their individual masses from the periodic table, and add them up. So I've solved an example for you. If you want, you can pause the video and kind of glance over it, make sure that you understand what we mean by empirical mass. Quickly going back to step number 1, I forgot to mention this. Just because you don't have empirical formula does not mean that you cannot find it. I'm stressing this again and again because it is important that you realize this. Most of the problems, empirical formula will not be given. It is not always going to be given, but you need to find it. Okay, so once you find the empirical formula, then you will find the empirical mass, and once you find the empirical mass, you will go moving along. In step 2, we're going to do molar mass divided by empirical mass, And so in this case, molar mass was given to you, and empirical mass is what you found. Remember, molar mass is always given, empirical mass needs to be calculated. And so I hope you recognize the little color coding thing that I've done here, so that you know which one's always given and which one is calculated. Obviously, step 2, where you will divide your molar mass, which was given, by the empirical mass, which you calculated, and then proceed to step 3. You got this as your answer, right? 6 in this example, you got 6. Remember, this will always be a whole number. And sometimes you might get 6.00 something or 5.99 something. So as long as whatever answer you get, it's fine if it is in decimals, as long as it is 0.9 something or 0.0 something, and then depending on what you got, you can either round up or down, but you will always end up with a whole number. Now you're going to take this whole number. So in step 3, you're going to multiply the whole number from step 2. So if you go back to, and you are going to multiply this whole number from step 2 with the subscripts of the empirical formula. So you will take, in this particular example, 6, and you will multiply each of the subscripts. And so for C, your subscript was 1 multiplied by 6, H was 2 multiplied by 6, O was 1 multiplied by 6. And so you get 6, 12, and 6, and what you end up with is C6, H12, O6. So this is your molecular formula. So as you can see, as long as you have the correct empirical formula, the rest of the process is actually pretty simple. So I'm going to give you one problem, and I have given you the steps for this problem. When you come to class, I expect you to work this problem out on your own, and then you can check your answers when you see me. So in this example, I've given you that you have 28.2% nitrogen, 20.8% phosphorus, 8.1% hydrogen, and 42.9% oxygen, and its molar mass is 149.09 grams per mole. Remember, this is always given. So what you're going to do is you're going to find the empirical formula first. For this, you are going to use percent composition. And so these are your steps. Basically, you will find the empirical formula. From that, you'll go to step 2, find your empirical mass. Molar mass is given, remember. Then you will divide your molar mass. So step number 3 divided by step number 2, and this is going to give you a whole number. You will take this whole number and go back to your empirical formula, and you are going to multiply the whole number with the empirical formula, and you will get your answer. And so it is a pretty straightforward process, as long as you practice. Basically, that's all there is. And so we'll do some more problems in class. Hopefully you guys understand this video, and when you come to class tomorrow, you're prepared and ready to do some problems. So I'll see you in class.